Blender for Noobs.
Hello, this is Dan Nobles and welcome to Blender for Noobs and welcome to this lesson, Understanding 3D Modeling. Now, if you're taking the course along with this, this is lesson 2 of the course, Blender 3D Modeling for Beginners. Now, in this particular lesson, we're going to be learning a little bit about the different types of modeling. So you really don't even have to open up Blender for this. And I know a lot of you just want to jump right in and get to modeling some objects and learn how to model. But what I've seen in a lot of modeling instruction is the information that I'm going to give you is often just passed over. And I think it's very important to know this information as sort of a foundation for learning 3D modeling. So when you do get to modeling things, and we will be modeling something in the very next lesson, then you'll have a much better understanding of the building blocks needed to create what you're creating. So let's get started. So let's talk a little bit about the different types of 3D modeling that we have. First of all, we have polygon type modeling or polygonal type modeling. And that's the type of modeling that we're going to cover in this course. And then we have NURBS type modeling or curve type modeling. And we're also going to cover some of that in this course. There's also a few different types of modeling that we're not going to be covering, but that does exist, and that is digital sculpting, procedural modeling, and image-based modeling. And we're going to talk a little bit about all of these in this lesson. So starting out with polygon type modeling or polygonal type modeling, this is probably one of the most popular type of modeling, ways of modeling that people do when they first start 3D. And in fact, some people love that type of modeling and they stick with it, or they may move to different other types. Well, what is polygonal modeling? Well, when we look at this cube here on the screen, and again, you don't have to open Blender for this, you can just follow along with what I'm doing. I'm going to tab in edit mode here, and I'm going to choose face, and I'm going to select this part of the model right here. This is called a face. And I'm just going to choose Shift D to duplicate it and move it out here so we can better see this. This is an example of a polygon. It's a polygon with 4 sides, which in effect makes a square. And we use these different shapes in polygonal modeling in order to create our objects. Now, they don't have to be 4 sides, of course. They can be a number of other sides. For example, if I chose these 2 vertices here, and I chose W and did a subdivide, we have a vertex in the middle, and I could pull this up, and now we have a pentagon. Still a polygon type of object, but just with an extra vertex in there, so we have more sides. Now, in polygonal modeling, normally you deal with what they call quads, which is the 4 sides. So if I'm just going to merge these 2 here. Alt-M and just merge at first. And we'll just move this over. So it's a square again. In polygonal type modeling, quads, or what they call when you have a square like this, is the most preferred. Now you can also have what they call tris. So if I merge these 2, do it Alt-M, merge it last. Now we have a polygon with 3 sides, basically a triangle. And these are called tris. And probably the most places you'll see tris in the modeling is things like when games are created, models for games, and you'll see a lot of tris in that. But normally when you are creating your standard models, it's recommended to only use objects that have quads. In other words, if let me grab face here again, these are all quads. And the reason for that is just the way that the geometry reacts when you go to render it and you put the lighting effect on it and all of that and the way you subdivide. But we'll get into some of that as well. So when you think about polygon type modeling, if we do a Shift A and we look at our add menu, then we can see that under mesh we have all these what they call primitives. They're called primitives because these are the very first objects you can start out with in order to create your model from there. So for example, if we took something like a UV sphere and put it out here, and we tabbed into edit mode, we can see that the sphere is really made up of all these quads, all these what are called faces. And everything that you do to your model beyond that, say if we extruded this, moved it out and extruded again, took this, extruded that, everything that you do is going to be some type of polygon type of shape that's going to create that. And that's why this is called polygonal modeling. So I'm going to go ahead and delete this sphere and tab back in edit mode, and I'm going to delete this here, X delete faces. So we're left with this cube again. Now within polygon type of modeling, polygonal modeling, there are two methods that you can use to model. And first one is called box modeling, or otherwise known as subdivision surface modeling. Now the reason it's called box modeling is because, say for example, you took this cube, you're going to take this entire primitive cube and you're going to make your object from that. So for example, if I have my cube here, I could do this and choose E, scale it down, E, extrude, come up here, E, scale it down, E, extrude, and start making some kind of object from this cube object. Also, when we created these extrusions, what we really did to the first original cube is we did some subdivisions. As you can see here, we now have on this area, we have 1, 2, 3, and there's a face back there, makes 4 more faces, where we originally had only 1. Another thing that you can do as far as subdivision, if I choose Shift A and create another cube, just going to move it over here, you can add things called edge loops. I'm going to do a Control R to add an edge loop. And I'm going to move my mouse wheel up, and you can create a lot of subdivisions here. I'm just going to create 2 of these edge loops. So if we go back to face select, you can see that we've subdivided the face into various pieces. I can add more. I can do a Control R, add a few more here. And let's go back into faces, and we'll see all these different subdivisions. So when you start to subdivide an object in modeling and polygonal modeling, what you're really able to do, say if I took this face and I just moved it out, took this one and moved it out, and actually I could choose vertex mode and I can start changing these surfaces a little bit. You can see that this surface is starting to become curved. Now this is a very rough example, but you can imagine that if you subdivided this many, many times, the more subdivisions you have, the smoother this object would get. So that's how, when you're using polygon type modeling, you can actually create things like a human form, a face, things in the real world that are smooth in nature. So that is the box modeling method or subdivision surface modeling method of polygonal modeling. The other method of polygonal modeling is called edge modeling, or also sometimes called contour modeling. And I'll show you what that is. So let me go ahead, I'm just going to delete these. And in order to give you a good example, I'm going to bring in a background image of a car. Okay, so here is an image of a Cooper car. And say if we wanted to model this, we could start out by using a cube and subdividing from there and creating the car. But there's also another method we could use. And in fact, you can mix the 2 different methods as you see fit. But say we wanted to create a contoured space such as this fender. Now this fender doesn't work very well when you do box modeling, because box modeling pretty much uses straight lines until you start manipulating. So if you think of something like a car fender or something like the shape of a human eye, then it gets a little bit hard to use box modeling in order to create that. And many people like to use the edge or contour modeling in order to accomplish this. So how do you do that? Well, instead of using one of the 3D shapes, we'll do a Shift A. We'll go back to Mesh. And we're not going to use any of these pre-made primitive 3D shapes. We're going to use this plane to start out with. And I'm just going to G move it down here, and I'm going to rotate it along the Y. So RY 90. Just rotate it at 90 degrees. Now, really what we have here is a 2D object. It's just a plane. So I'm going to choose 3 back into my side view. And by the way, we could have added a cube and just removed all the other sides of it. It's the same thing. But luckily in Blender here we have the plane already available to us, so I just chose that. So what we would do with this is I'm just going to S scale it down, and let's move it over here. And I'm going to tab into edit mode, and I'm going to choose Z for wireframe so I can see through it. I can see through, so I see my background image. And I'm going to select it again, scale it down a little bit, and let's just start right here, and let me rotate it a little bit. Okay, so now we just have a plane, and if we chose two of these vertices, and I'll get into the different components of this 3D geometry after we go over the types of modeling. It's the same thing as if I choose the edge here. So this is sort of why it's called edge modeling. Then I can do an E-extrude, scale up, E-extrude, scale up, E-extrude. And I can rotate it a little bit. Let me back up a little bit. Scale it up a little bit. E-extrude. Rotate. Now I'm doing this very quickly. Of course, when you do it, you want to take a little bit more time and make sure you fill in the correct areas here. But this is just to give you an example of how you use edge modeling in order to create a surface. So once we have our basic fender shape there, we could continue on and modeling the entire car just by extruding out our different panels here, different edges that we've created. So if we choose this edge, in fact, we could say we really need to subdivide this edge because there's a piece there. So I can do a Control R, add an edge loop there, and then choose all of these edges, E-extrude, and then extrude them out. Of course, there's some pieces here too that we need to worry about, and we might take this vertex and just move it up to where it needs to be here. Go back to edges and just E-extrude all these out as far as we need to. And then of course, once you have created all your edge pieces, or as you're working on your edge pieces, you also of course have to worry about what it's going to look like from the front view and all of top view and all of that. So in other words, it might curve in a little bit like that as you start to create your fender. So this is sort of like a piece by piece modeling where you're taking your faces and you're just covering the entire car and modeling it in this way. Now, one method is not any more correct than the other. Both can be used, and in fact, like I said, you can start out with something like box modeling and then decide, you've got so far that you want to complete this type of a little bit more difficult area with edge modeling and then connect them together. So they can be used interchangeably. So those are the two methods of polygonal type modeling. Let me go ahead and I'm just going to delete this and remove my background image. And like I said, we will be covering both the different methods of polygonal type modeling in later lessons. The next type of modeling is called NURBS. NURBS stands for Non-Uniform Rational B-Spline. And in order to get a better understanding of what that really means in the 3D modeling world, you can look up the different definitions of NURBS and how it relates to 3D modeling. But basically, NURBS are a type of way to model with curves. So in other words, if we choose Shift A, and instead of our mesh menu, which deals mostly with polygonal type modeling, we can go to Surface, and you'll see all our NURBS surfaces here. So if we choose a NURBS curve, create that, we have this curve here now, and we can tab into edit mode, and we have a number of segments here, these little areas here known as handles, and we can go ahead and we can G move those around as needed. We can also do E-extrudes to make the curve larger. We can also extrude downwards. So if we do, I'm just going to do a select all and choose E-extrude, and I'm just going to move this down. And I'm still in wireframe mode, so I'm just going to choose Z so you can see this here. So what I've created here is basically just kind of a looks like a piece of sheet metal, but it's all done with curves. Now curves, as you can see down here, we don't have any vertices or edges or faces. It doesn't use that. It uses all the curve type of geometry in order to create this. Now, why would you use one type of method of modeling over another? In other words, why would you use something like polygonal type modeling versus NURBS modeling? Well, NURBS modeling is used very heavily in the automotive and industrial areas of modeling. That doesn't mean that if you want to model a car for your own personal use, that you should use the NURBS modeling method. You can definitely use the polygon type of modeling method. In fact, most people do that. Generally, when you're learning modeling, you find that when you work with NURBS, you can create curved surfaces much more quickly, such as a vase or a wine glass of something of that nature, than you can with the regular polygon type of modeling. But we're also going to be covering NURBS in a later lesson. And also along with this type of modeling, when you speak about curves, I tab back into object mode here, and I'm going to do a Shift A. You'll see another type of modeling tool here, and this is the Bezier curve. Now, the Bezier curve is similar to the way NURBS work. It's also using curves. It just uses a different type of algorithm and method in order to create these. So if we choose curve and we choose Bezier curve, we now have another type of curve, but it reacts a little bit different. So if we tab into edit mode, you can see the direction of the curve here. You can see that the handles are a little bit different. You can rotate them like this. You can choose the middle of the handle here, E extrude and R rotate. And they're a little bit more flexible, I think, when you start to use them. But you'll also notice if I try to do the same thing I did with NURBS, if I choose A, select all, choose E to extrude, they don't extrude. So they work a little bit different than the way NURBS do. And if we pull this menu over here, we find that we have some properties here we can work with. And we're going to get into working with Bezier curves as well. But I just want you to be aware that they are available for you to use, and there's different cases where you will use them. And as we get into the different lessons and look at them a little bit more closely, hopefully you'll be able to see a little bit, or get an idea on when you would use these versus other types of modeling. So I'm just going to tab back into object mode, choose X to delete these. So those are the types of modeling that we're going to cover in this course and later lessons. Now let's talk about some of the other types of modeling that we're not going to cover. There is something called digital sculpting. Digital sculpting is where the artist can use something like a tablet in order to almost use it like a sculptor would trying to create a clay model. And in many ways, it's much more intuitive to the artist. It gives them the ability to express the aesthetic value of the art a little bit better, I think. And you also can work with models that get up into, really, really high detail in order to create 3D objects, usually something like a type of character that you would create for a 3D movie. So that's digital sculpting. Another type of modeling is called procedural modeling. And procedural modeling you can kind of think of as the computer doing all of the modeling work, or at least most of it. Say, for example, you wanted to model a mountainside or some kind of terrain that goes on for quite a distance, and it has many peaks and valleys in this terrain. Well, you can, use your different types of modeling to try to create this terrain, but many times when you're trying to create something that's extremely large and complex, it's very time consuming, and that's where things like this can more easily be done with some type of computer algorithm. So when I think of procedural modeling, I many times think of the program View, because in View what you can do is you can create a mountainside or some type of terrain, and you can give it parameters so that the program knows roughly the kind of peaks and valleys and kind of shape that you're looking for. Now the downside, of course, to procedural modeling is you're going to get only what you put into the parameters of the computer. So If you're looking for something very specific, you want your mountainside to look just so, then you may not get what you want with that generator. You may have to actually go in later on and tweak the model that the computer created or something to that effect. So that's procedural modeling. Another type of modeling is called image-based modeling. And also in this case, usually some type of computer algorithm is used in order to create the model from the images given. Now, an example of this might be if you have this high-budget Hollywood movie and you want to put some sort of background in, but yet it should have some kind of texture to it or some kind of 3D modeling going on there, then you would use image-based modeling as a cheap method in order to create the backgrounds. But everything else you see in movies that is created with CGI is usually using some other type of the modeling methods. In fact, when you watch a movie, especially now, even if it's not a CGI created sort of animated cartoon or something like that, something was created with computer, if you watch live action a lot of times, you'll see the characters in backgrounds and things, and you'll see objects sitting on tables, which may have never been there. They look completely real. We're, pretty much at the point now where when we see something on the screen, we really don't know if it's real or not. So those are the different types of 3D modeling. Now let's step back a little bit, go back to polygonal type modeling, and let's look at the geometry that the 3D object has. So if I do a Shift A, and I'm going to go back to mesh here, and I can choose any of these primitives here, but I'm just going to choose the cube, just because it's easy to use in order to explain 3D geometry. Now it doesn't matter if we talk about, in this case, the two different types or two different methods of polygonal modeling, whether it be the box modeling or edge modeling. The components of the objects are completely the same, the actual geometry. So let's look at that. If I tab in edit mode, we can see the components. So we have three different components down here. This is called a vertex, this is edge, and this is face. So if we choose vertex here, we can see these little points highlighted on the object. These are the actual vertices. This is the smallest component of geometry that you can have on this 3D object. You can think of this point as almost like a non-physical type of point. And what I mean by that is it holds these three edges together, but I can't rotate it. It won't do anything. I can't scale it. It won't do anything. It's almost like an atom. But if I move the position of it, then it will change. So when you're manipulating 3D geometry, that's really the only thing that you can do with a vertex is move the relative position of it. But if we go over to the edge, we can think of edge as sort of like more physical, because if we choose an edge, then we can rotate it, we can scale it, and we can also move it. And an interesting thing happens when you choose an edge. If we go back and choose vertex, we'll see that what we've really done is we've chosen two vertices, which makes up an edge. So those are edges, and as you can see along the cube we have all these different edges made up, and the smallest component has different vertices at the different points. And then if we go to faces, which is denoted by this little square dot on each face, we can select faces. And as you might guess, when you select a face, if you go back to edges, you've really selected 4 edges. That's a face. And this is basically the face of the polygon. And if we go back even further to vertices, you can see that you've really selected 1, 2, 3, 4 vertices. It's the same exact thing. It just means that when we're manipulating our objects, when we're modeling, depending on the level of detail that we need and what we're doing, we'll be using faces to move things around and scale things. We'll be using edges. So if I chose one of these edges, I can do something more specific to this object. And we'll be using vertices. So if I chose one of these vertices, I can get even more specific on how I move the object. So you can think of the different components, the different geometry that exist within this 3D object as really just varying ways of manipulating the object. But using just these three basic components, you can create any model that you have seen pretty much anywhere. And you'll notice if I do something like a Control-R edge loop and add that in there, and then choose vertex, select here, you can see that anywhere that the edge is bisecting another edge, you're going to have a vertex. And that only makes sense because if you didn't have one, say for example right here, you wouldn't be able to move this part of the object anywhere else. It would be stuck in that area. So I wouldn't be able to do just that. So again, anytime you add some edge loops in here, you're creating more and more vertices, more and more edges. So you can see the different edges here. And these are all subdivisions of the entire object. And of course, you're creating more and more faces. So you have separate faces, and you can extrude them into more and more faces, or scale them down, or whatever you need to do to your object. Okay, so that's a very basic idea about the components of geometry within a 3D object, but at least having some beginning idea of what those things are, I think makes it a little bit easier when we go forward and we start creating and modeling actual objects. So next, in lesson 3, in manipulating 3D objects, we are going to actually getting into doing some modeling, and we're going to learn more about how to add on to our model and how to manipulate it within the 3D workspace. We're also going to get into a little bit of using the camera to render and also light our object, because I know one of the things that people really want to do, once they create something, is they want to be able to get an image of it, show their friends what they're doing, things of that nature. So we'll be setting up some of that as well. So I hope you enjoyed this, and I'll see you in the next lesson.